Okay, here's some lessons on geometric sequences. Geometric sequences are sequences that are being multiplied by some sort of common value. So here in this case, I am being multiplied by the same value each time, so it means it's going up by 3 multiplied by 3 each time. Now the letter we're going to use for what's being multiplied is R. So your common ratio, so my common ratio is 3. Your U1, which is your first term, other books will use T1 or they'll use A as being your first term, is, in this case, it is 2. My U1 is 2. If I look at this other one, which is going from alternating from positive to negatives, from 2 to negative 6 to positive 18, okay, to negative, and that should be 54. Here I am multiplying by negative 3, going by negative 3. So my R would be negative 3. If it's going from positive to a negative, it means you're multiplying by a negative value. And my first term is again a 2. How to figure out the R? In this case, you'd actually divide any two consecutive terms to figure out what your R value is. For an arithmetic sequence, you subtract the two consecutive terms. For geometric, you divide two consecutive terms. So an example of this is if you have 3 terms, they're all consecutive terms in a geometric sequence, find B. So what I would do is I want to take two consecutive terms. I'll take like my second term and my first term, and I want to divide them. Second term divided by first term equals, and it'll be equal to the same value as if I take my third term, 63, and divide my second term. And now I can try and figure out what my B value is. Now here I have a fraction equals a fraction, which means I can do cross multiplying. Now we get B squared equals, and 63 times 7 is 441. I'm going to take my 441 over to the other side and subtract it, make it equal to 0. And I can actually, I can factor that, because that is difference of squares, and it becomes B plus 21, B minus 21 equals 0, which means that B will equal negative 21, or B will equal positive 21. Here you have quadratic, so it's important to get over to the other side and make it equal to 0 and either factor or use the quadratic formula to solve. Okay, so if you divide two consecutive terms, you can figure where your R value is, and in a geometric sequence, the R value will stay consistent all the way through. The general two-term formula for a geometric sequence is UN equals U1 times R to the n minus 1. So let's find the general term formula. Here is a sequence that I have. So my first term, my U1 equals 9. My R in this case, it is being, well, it looks like it's being divided by 3. So I want to say it's being multiplied by 1/3. Your R value is 1/3. If it's being divided by 3, your R value is technically 1/3. You can't say divide, you're going to have to say multiply. So you have to adjust. So your general term formula, UN equals U1 times R to the n minus 1. So it's going to equal 9. Your R value is 1/3 to the n minus 1. And that's all you can do right now for your general term formula. Do not multiply these two together. You cannot multiply the 9 and the 1/3. This is the base on an exponent. Okay, so you're going to follow BEDMAS rules. You got to do your exponents first before doing multiplying. So do not multiply these two together. Leave them separate. Find the 8th term. Now that I have my general term formula, I can find my 8th term. So UN, which is just any term, future term I want to find, equals 9 times 1/3 to the n minus 1. So I'm going to put in, I want the 8th term, so n equals 8. N is just what term I'm finding. So I'm finding now U8 equals 9 times 1/3 to the 8 minus 1. 9 times 1/3 to the exponent of 7. So do the 1/3 to the exponent of 7 first. Now, fraction to an exponent means that the exponent goes to both the top and the bottom. 1 to the exponent of 7 is still just 1. And 3 to the exponent of 7 is 2,187. Now I can multiply this together and we get 9 over 2, which can be reduced to 1 over 243. Okay, so make sure you do your exponent first before you actually multiply by the coefficient in front. Okay, this is a very short lesson on geometric sequences. This is your general term formula. un equals u1 plus r to the n minus 1. And you have R formula where you're dividing two consecutive terms. It can be useful in finding unknown values between in a sequence, okay? And also remember, anytime you have a squared in an equation that is quadratic and you'll have to rearrange it and factor or use the quadratic formula. Thank you very much.